Thank you everyone for attending the very first Montreal Dataops meetup. It's a pleasure to see you all here, and it's going to be an even greater pleasure to see the community grow in the upcoming months and years. So my name is Pierre Clich. I am the host of the meeting, one of the co-organizers. Well, we will not be wasting any time today, and we'll get right into it. So I would like to introduce our speakers for this meetup. Oh, I see we have somebody else joining. Yeah, so I would like to introduce the speakers for the meetup, which would be Nasko Grozdanov and Naji Bessa. They will be going over a presentation on DBT. So without further ado, I guess I give you the floor. Just one thing I would ask of everybody is that you guys remain on mute for the duration of the presentation, just as a measure of respect for our speakers. All right, let's get this rolling.
Okay. Oops. So hi, everybody. Today, it's going to be my pleasure to talk to you about the realm of possibilities with DBT. So first, before I start, we were introduced, but I just want to reintroduce us. My name is Nasko. I'm a solution architect at senior solution architect at Infrastructs. And with me today is Naji, who is also a senior solution architect at Infrastructs.
Everyone.
Now today, I've split up this talk into three parts, which I think are just normal questions to ask when you're looking at a new tool to do a significant job, which is, first, what's the context in which the tool operates and what's like using it? Do you like it? And what are the trade-offs, right? Because every tool has trade-offs. So if we go right into it, what exactly is DBT? So as they like to say in their motto, DBT puts the T as in transform in ETL, right? But what you need to know is that it's a very small command line application that is written in Python, and you specify your models in SQL, vanilla SQL language, which is augmented with a little bit of Jinja 2 templating. And what it will basically do is send commands to your data warehouse to perform transformations. And it itself has a very minimal folder structure, and the use of SQL gives it a very concise syntax. But more importantly, because it's a command line application written in Python, you can run it almost anywhere, right? Now, because DBT can give transformations a more broad appeal than just to the typical big data engineer, I would just like to start with giving a broad explanation of what ETL actually is, right? So ETL stands for extract, transform, and load. Extract meaning that you're getting data from different sources. Transform meaning that you manipulate that data to make it make it look how you want it to look. And then load as in you store it in a data warehouse of your choice. So if I give you a typical example, if you have a user visiting your website, well, you might want to track him on the website. You might want to know which customer support messages he's given you. And you might want to know which newsletters he received that you sent through like SendGrid, for example, right? But this poses a problem when you're trying to merge all that, which is that, a user can have a different name in all these tools. And variables can have different names, can be written differently. And the data that's contained can be inconsistent across tools, but even inside of tools, right? So you can imagine that, this probably won't happen with a very big SaaS tool where probably there will be very homogeneous, but if you've built an internal tool, you might have Canada written in 4 ways, right? So that's the broad thing. So you would put the transformation part into 2 broad categories. The first one being data cleaning, which is where ensuring that you have this high quality, consistent data across all the tools. And then data modeling, which is where you're trying to make your data useful by representing it in logical concepts that are consistent across the different sources. Now, if you look at the transformation landscape today, you can kind of put it into 2 categories, right? On one side, you have SQL-based tools, and the other side, you have, tools that expect you to use a programming language such as Python, JavaScript, etc., right? And to be perfectly transparent, I personally fall in the category of preferring to use Python traditionally. That's my comfort zone by far. But if you're using DBT or tools that I would typically use, what does this look like? Well, with DBT, you have to learn vanilla SQL, and you have to learn a bit of Jinja 2 templating, which is also optional. Whereas if I were to do this in Python, as I've done for many years, I would get to use Python, which is a very nice language, but I'd have to use a variety of libraries and tools that are all evolving separately and are not always compatible with every version of Python, and they have quite the learning curve, right? But if I were to do that, what did it typically look like? So it would typically look like me extracting data from these sources and storing it in a bucket or some sort of storage mechanism, and then downloading this data onto a cluster, typically a cluster of compute nodes, where I would actually copy the data onto them and perform transformations myself that I'd have to write myself using Python pandas or Dask. And right away, I have to manage this infrastructure and I have to make sure that I'm not going above the load capacity of the infrastructure. And if it's taking too long or something, I need to make sure that I can parallelize all this nicely so that it happens in a reasonable amount of time. And once all that hard work is done, then I put the data into a data warehouse, right? Now, I'm sure that I'm not the only one who's tried this. So I guess as a first question, something I'm interested in hearing is if other people have done this and what was your experience? Was it easy? Did it work out of the box?
So Jean-François, we're gonna put you on the spot there and ask if you can maybe give us your impression as far as
Yeah. Hi everybody. I'm the engineer, work at Square Enix Montreal in the gaming mobile industry. Yes, we tried that route with self-coding. What we did, we use actually a framework. It's called Apache Beam. So you can program in Python, Java, and a bit of Go. And you can run that framework on your local machine. You can run it on different runners, like a Spark Links. Personally, we use a GCP Dataflow. So what GCP does is handle all the infrastructure, so all the VMs, the compute nodes, etc., and you can scale it as you want. So that's a way to do it, or you can do it manually, like the presenter did. So that's my experience with that.
Cool. And in your team, like how many people are you in your data analytics team?
I was the only one.
The sole contributor? Okay. That's a lot of pressure. No pressure.
Yeah, it took me a while to learn all these things, GCP, Apache Beam, etc., and how to make this work. Like we had like the data initially in buckets in AWS. We transferred it to GCP, and then we run the Apache Beam ETL on Dataflow. And then we stored that info in a BigQuery data warehouse.
Okay. And Apache Beam, like how does it handle the versioning of the different components through it? Is it all managed through the framework, or is it like, did you have to go in and do a lot of tweaking to make sure that things are kept operating as you may upgrade a component or a piece of it?
It's up to you. The Apache Beam code, like it's just normal code. So you can put it in version control, you can deploy your pipeline and all the other pieces that you need that are not handled by Apache Beam using whatever you like. If you're on Google Cloud, you can use like Terraform, you can use directly G-Cloud commands. Personally, I don't know Terraform at this moment, so I use G-Cloud commands. So I add shell scripts to deploy the complete end-to-end pipeline. And the Apache Beam code was like one part of it.
Okay, neat. Pretty neat.
Okay, well, honestly, that's very consistent with my experience as well, right? Because you have to take ownership of the cloud infrastructure. You're dealing with multiple tools, some of them from Apache, different languages. I mean, you have quite a lot to take on there. You have quite a learning curve, right? So, like from my point of view, that's the big thing about this. So you get to use languages you love, we all love, and things like Python, extremely popular, growing like crazy. But that's my experience, is that you have a huge learning curve, right? And that can be, first of all, it can be intimidating because you have to master all these libraries and tools. Then you also have to manage the infrastructure. Both of these are daunting, but more importantly, even if you get it to work, it's a complex system. It's a very complex system. And that means that it can be prone to error. And it's it feels like a big achievement when you're able to do it, but maintaining that over a long period is quite a strain, right? So that's why, like if you compare this with using DBT, the approach is pretty different. So instead of managing all the parallelism and the complexity yourself and the infrastructure, essentially you have a CLI app that you run, in a build step typically, or even on your laptop. And what it will do is just it will compile your model into vanilla SQL statements that it then sends to your data warehouse. And the data warehouse, you're delegating all the engineering complexity to the data warehouse. You're using its ability to perform, to handle parallelism and scalability. So most of the engineering complexity is delegated, and your technical debt ends up being very low, right? And what you're left having to do is to specify what you want as transformations. And in this case, it's done as SQL. It's a SQL select statements, right? So in this case, we're joining two tables here, the orders and the customers. And we're basically, yes, there is some implementation details here. You're using some SQL functions, but overall, you're largely just describing the final state of what you want, and you're not really handling implementation as such. So if we compare them as they scale, if you scale, again, you're delegating the complexity to a data warehouse, and your responsibility doesn't really change. It doesn't scale with the data scaling. But if you're going, for example, the Python route where you're managing all this yourself, as the data scales, the complexity and the scale of what you have to manage grows. And so inevitably, that's quite the burden. And there's some side effects from that as well, which is, for example, here, the data never leaves the data warehouse. You're just instructing some commands. But with this approach, you actually copy the data onto these machines. And there's some inherent security risks, but more importantly, there can be some data drift. There can be some inconsistencies between the two. So that adds a bit of technical risk. So if I were to give a summary of this, the things that really matter to me, again, scalability is delegated. It's declarative, it's concise. And this lends itself very, very well to data as code, because most of the code that you're writing is just describing the transformations that you're looking to get. So that's sort of the broad overview, right? So now I'd like to go more into the details, like what does this look like, right? Because you want to get a feel for it, whether you like it, whether you'd be willing to use it. So if you're starting a project, this is a simple Python CLI app. So if you have pip installed, you can install it just like this, which is my preferred method. But if you're using Mac, you can use Homebrew, right? Once you have DBT installed, you just create a folder in which you want to create your project, and you do a DBT in it and give it a name. So this is very simple, and it's reminiscent of other tools you use. So that's what it does. It creates a project, a file, and a folder structure that informs DBT that this is a DBT project. So what does that folder structure look like? So first you have basically two configuration files that inform DBT. The first one is a profiles YAML file, which is kind of a general set of configurations that apply to all your projects. And then a project definition YAML file that's just specific to this project. And it will also create a few folders, but there's really only one that matters, which is the models folder, which will contain your models. And your models are defined as SQL select statements in individual SQL files, right? And that's enforced, and it gives a bit of structure and cleanliness to your work, and just makes it very easy to understand what's going on just with the folder structure. Now, any subfolders of the models folder will be detected by DBT, as in any SQL files that are in those will be detected by DBT. But if we're looking at, if we consider ambiguities that can arise, I think it's largely distinguishing between the profiles and between project configs. So let's look at that. So profile is kind of a configuration that applies to all your projects. And the primary thing that you're going to do here is specify your targets, as in the data warehouses where you would be, that DBT would connect to and perform transformations, right? So in this case, you'd be specifying the host credentials, which you're probably better off not writing them directly in the files, but having them as environment variables or handled through some sort of secrets mechanism. And then you can specify, for example, default databases and schemas, but these are just default ones, right? And again, credentials should not be stored in this file. Then when you actually create a project, you have more fine-grained control, right? So you can specify that you want to use the default profile that you created, but then for every single folder inside of the models folder, you could, for example, specify, you know, for the staging folder, I want to refer to the staging database, and I want all the views, all the models materialized as views, which I'll explain in a second. And you have a bunch of parameters that you can use. And again, some of these can also be overridden at this individual SQL file. Now, what's a materialization, right? Whenever you create a model, you know, DBT will have to actually perform operations on your data warehouse. For example, creating a view, creating a table. And when you're specifying materialization, you're just specifying which form you want this model to take in your data warehouse. And there's a few options right here off the bat. You have view, which is a lightweight, essentially a lightweight structure that points to other tables. And the advantage here is that the data is always up to date, but the disadvantage is if that you have very heavy transformations, the performance can degrade. So if you have heavy transformations, you need better performance. You can put the data into a specific table for that, but that comes at the disadvantage of actually duplicating data, and it doesn't anymore point to the original tables. So data doesn't automatically get updated, right? Once the columns you're using and the representation you're using is kind of crystallized in your project, you can move on to using an incremental materialization. Basically just means that you're adding new records as they come in, and you're not recreating the table every single time. So obviously this is advantageous from a performance point of view, but it does require that you have a crystallized representation in order to be beneficial, right? So what do the models actually look like? So every single model has its own SQL file. The name of the model, which for example would be a view created in a data warehouse, is the name of the file, although it can be overridden. And then the result of the select statement is what will populate the view or the table. And this happens, you know, when you execute the run command. Now, different models can refer to each other, for which there's a function called the ref function, and then that builds a dependency graph. Again, that's not necessary fundamentally. You only need that if you have a model that depends on another, right? Additionally to the SQL, you have Jinja 2, which adds some syntactic sugar. So for example, you know, you might want to return just a part of the data, not the whole data if you're in your dev environment. Well, with Jinja templating, you can do that, right? And using Jinja has some advantages because it's fairly commonly known. If you ever written like a Flask app, or if you use like Django templating language, you know, that's what Jinja is supposed to recreate. Another useful thing here is, for example, you can check if your materialization is incremental, in which case you can add a where statement to just return part of the data that's new, that's fresh, that you might want to add, right? And so the inclusion of Jinja, it adds some functionality. It adds control structures, environment variables, macros, even for loops, right? So you can have a set for example, and have a for loop on it that DBT will then compile as, you know, vanilla SQL, but this allows you to avoid repeating some of your code. Now, when it comes to actually running it, right? There's a couple steps here. I mean, firstly, DBT has to take that folder structure and go ahead.
Sorry, Nasko. There's a question in the crowd. Kima?
Yeah, Nasko, I wanted to ask, is the SQL in DBT different for different targets where you execute it? Or is it sort of generic and DBT figures out the differences depending where you point it to Snowflake, Redshift, whatever?
Yeah, I mean, the generated SQL will be different, right? I mean, you have what's called an adapter that you can specify. For example, specifying an adapter for Snowflake because some of the code, I don't have an example here, but you know, this, if you've specified a table or a view as a materialization, it will go like create or replace view, right? And that's specific to Snowflake. It can be, in, you know, the syntax differs a little bit from Redshift or Postgres, for example.
Okay, but the adapters are helping you write in as standard and generic form as possible.
That's the goal, right?
Yeah, okay, thanks.
There's another question from Naji.
Yeah, go ahead.
Actually, quick comment. I just wondering if you maybe can speak of using like if not flag as you declare some statements in an effort to not have to, for example, overwrite some resources or deal with conditions whereby a resource exists, you may want to run your code again and limit the number of errors you get from that.
Sorry?
No, I was wondering if you could speak of like when you declare, for example, a resource, using the if not exist clause as a mechanism for being able to rerun your script if you need to, and for resources that have not been created or that have been created already, giving your script the ability to skip them because it can validate the existence of that resource and therefore skip to the next kind of set of resources.
I mean, that's the thing, right? So when you're running DBT, it will actually build a dependency graph, right? So does that answer your question? Because you can do, for example, a full refresh, right? This is a good example. So if you have an incremental materialization and you run DBT, it will only add the incremental data, right? But if you need to do a clean wipe and you want to rebuild those tables because you changed the representation or you changed the columns and it's no longer appropriate for an incremental materialization, you can run it with a full refresh.
Cool.
Yeah.
I actually have another question.
Go ahead.
In concrete terms, is running DBT with a full refresh, does that mean that you will be essentially destroying all of the constructs that were built by DBT in the past and then reconstruct them?
No, presumably, yes.
Okay, got it.
It's essentially, that's the difference between when you're specifying, that's the advantage of using like the incremental materialization, is that as new records enter, they're inserted rather than having the table rebuilt.
Got it. And then another question that came to mind. So you mentioned that one of the big advantages of using something like DBT is that you use a very simple language, which is SQL, right? Which is easier to share with other people in the organization, stuff like that. But then you introduce the notion of templating. And what I've seen in the past, actually, with Jinja 2 templating, is that you can actually cram a lot of logic in those templating tags. So what's the right balance, right? How do you avoid falling in a world where basically you're just running like intricate Jinja based Python scripts basically?
Yeah, I mean, honestly, that is a very legitimate question that I've been asking myself. For me personally, I prefer to avoid using it unless it's absolutely required. And that's just a personal preference. So for example, I would tend not to loop as they do here, just because I find that it makes the code less readable, unless we're talking about a very heavy, lengthy set, right? So personally, I do think there's a question of style here. The goal is to use vanilla SQL as much as possible because that's the easiest and most declarative document. It's basically self-documenting, right? But honestly, I could envision people having different points of views on this. Because I have also seen Jinja templating specifically for like Flask apps. I have seen Jinja templating turn into a bit of a mess.
Yeah, same.
But
sorry, go ahead.
But that's the thing. Any language that you use has potential, has that pitfall, right? So if you push C++ or Python or JavaScript to their limits of convoluted coding, you will have a headache. So I think it's just a question of adopting good style and having a disciplined
You're
approach.
right. DBT is using Jinja 2 for templating, but not necessarily to replace what DBT does, right? So if you limit, you're using it when it makes sense, like for environment differences or specific filtering on refreshes and stuff like that, makes sense.
Yeah.
All right,
but it's a very legitimate question for sure.
Cool. Thanks.
The payment method actually is a good one. I was thinking if you flatten, you have an enumeration stored as values in a column, and you want to kind of create in your model, you want to create for each value, start to do grouping and aggregation. That's a good one, right? You will need to look through the values in order to create dimensions or facts for each value, right? So that's probably a valid one where you want to use a loop.
But wait,
Yeah,
sorry, can you can't use your Jinja 2 logic kind of in real time as it's being executed, right? This is going to be run before it even touches the database to generate static SQL code, and then
it's managing the schema.
Yeah, which is what I mean. You can even use DBT compile. You don't have to run compiles it before executing it, but you can compile it as SQL files, and then it's going to be in your target directory, and you can check them out, and you can see what you created.
Okay, got it.
I mean, I definitely see legitimate uses of the Jinja templating language. But again, it can be a bit of a mess. I mean, like, for example, people have always loved Jinja because they found the syntax very obvious and simple. But I always found that it can, even the fact that you're using like curly brackets with percentages or whatever it's called, it can be visually heavy, you know? So it definitely requires some discipline. But again, that's true of most languages. I mean, if you're writing this in Python, you know, using PySpark or Dask, you're gonna have the same pitfall in other forms.
Makes sense. Thanks.
Yeah. So I've already explained that. So, you know, what does a development environment look like for this? So fundamentally, it remains very simple, right? You have your DBT code with the whole folder structure preferably in some sort of version control system in a repository. And that is loaded onto some sort of compute node that will execute DBT, run DBT, basically, and then deploy by basically sending those commands to that data warehouse, right? And here right away, we say that because typically the data you have in your data warehouse is business critical, you want to think about managing those credentials and not having them stored in your version control system. So right away, actually, from that previous diagram, there's like two considerations you can see that we, even at this very simple level, we took into account, right? DBT lends itself very well to data as code. So, and because it's concise and because you're really writing about desired states. So you really do want to involve it in some sort of CI/CD pipeline, right? Potentially with approval processes, but essentially you do want to treat it as code. And another consideration is that because your development environment can actually run transformations on your whole data warehouse, you want to be very careful about isolating it, you know, making sure that the scope of the rules that it has access to is limited and that the people and the machines that can connect to that development environment are tightly controlled. But those are just two challenges that come to mind. There's definitely other challenges, and that's why like our second question is kind of what are the challenges that everybody else has encountered in ETL pipelines?
I personally, one of my big challenges, and this may not be where you want to go with this, but I know that one of my big challenges in scaling ETL pipelines at a very large scale, specifically I'm thinking of, actually this may ring a bell to Jean-François, who is currently working for a video game studio. But in the past, we had to do a lot of data transformation for relatively high volume video games, and one of the challenges became simply managing state right across different nodes. It was extremely challenging to, like, for example, let's say that you had one of the nodes managing the transformation die mid-process. Being able to recover from that was an absolute nightmare. So this is definitely one that comes to mind, like one that was really non-trivial for me in the past anyway to handle.
For me,
yeah. Sorry, go ahead.
No,
go ahead. Sorry.
Go ahead. Finish.
That's called a Canadian standoff. Yeah, so basically what we ended up having to do is essentially maintaining a kind of a parallel pipeline all throughout every single step of the way to essentially just keep track of what data had properly been handled and what data hadn't. So this was before the times when messaging systems became able to gracefully handle dead letter queues and stuff like that. But yeah, definitely this is one of the ways. This is one of the things that were absolutely horrendous to handle at scale.
Yes.
I guess kind of coming from a more traditional world of on-premise and SSIS, like the scale was always always trouble, right? Like when you run something on SSIS, there is that one machine that has a certain, maybe it has a very powerful processor, but at some point it just dies on certain volumes. So the whole idea of processing large amounts of data in parallel is just becomes very, very difficult. And then the same thing with incremental updates. It was always a bit of a challenge to do it right. There are some patterns you can use, but it's always a bit of a copy and paste and a bit of a repetitive patterns that you have to put in, as opposed to what you're showing here, which is, well, just say incremental loads and suddenly everything works. So yeah, that was definitely one of the things.
On my end, because at the time my focus was more on infrastructure. It was to deal with the complexity of assigning, like an RBAC model for permissions to various assets when your authentication sources may not touch on all the levels of the data. So you have to figure out, at the cluster access level, a set of permissions, and then within the objects of the database replicate user level restriction within the database, which uses a completely different set of representation of a user. So figuring out the right map and having to come up with like custom code to do that and do it cleanly was definitely a big challenge. And then on the consumer side, having to think about the different, how to present a logic for the business users that we can then turn back into, again, a model where we describe that access well. So that were my biggest challenge.
Yeah, I've actually, this kind of reminds me of a scenario I encountered once, which is an issue I had going back, to this chart, which is where this is maybe less of a consideration if you're using AWS or a cloud provider, but on a supercomputer where I had to do this with, about 150 machines, I think, the actual copy operation from the central storage to the machines crashed the network of the entire university and supercomputer. And that's like one of those things where you have an endless, you have endless levels of complexity that you have to manage, right? And that you have to hope work out well. yeah, there's just there's a lot of challenges in scaling an ETL pipeline, right?
Yeah, with Apache Beam, and when you work with it on Dataflow, you can scale it pretty easily. There's some tricks that you need to know in your Apache Beam code, to unlock some bottlenecks and make it scale and distribute the data across many workers. But it's done pretty easily once you know these tricks, so you can scale it. You have auto scaling. You can specify ahead of time the number of workers that you want. So it's pretty good, and you don't have to manage the infrastructure. But there are some limits with the cloud providers, of course. It's not infinite. I made it crash at one point with auto scaling.
Which provider was that, Jean-François?
GCP.
GCP.
GCP, it has the Dataflow service on GCP.
Yeah, okay. Yeah.
All right. So I'm just going to focus on what scaling an ETL pipeline looks like with DBT, right? And this is an example of a pattern that we've identified, where basically once you really care about security to a very great extent, your developers can connect to a workspace through a VPN. Have multi-factor authentication. They don't have to adopt roles based on their entries in an Active Directory, and once they do that, they have access to the workspace where they can commit code into a repository and then have basically a build pipeline execute, right? And the actual build step is sufficient to send commands to your data warehouse to perform the transformation. So one of the things that right away always strikes me looking at this is that the only parts that actually handle your transformations are these two pieces here, right? Basically just your code pipeline and your code build. I mean, the vast majority of infrastructure you're creating otherwise is related to security largely. And this is infrastructure you have to create no matter which method you use, right? But overwhelmingly, the data transformation aspect here is really simple compared to the value proposition that you're getting and the effort that you're putting into it. But that does lead us into essentially the trade-offs. And I think that there are two trade-offs or impacts of using DBT to do this at scale, right? And the first one we've already kind of explored, which is because you don't have to handle the engineering complexity, you don't have to, you're delegating all that to the data warehouse. You have more bandwidth, and your bandwidth naturally shifts towards focusing on security because your data is probably business critical and it may well have compliance requirements. And I just want to drill on this, which is the fact that you're using very few technologies on very few machines in this case means that you have fewer points of failure. And that's really important when it comes to reducing, attack surface area, right? And when it comes to managing credentials and using RBAC, you have to do that for your cloud provider, and you have to do that basically in the data warehouse provider, but you don't have to manage that with respect to the tool itself. So again, fewer points of failure. I think that as a trade-off, you have a greater focus on security when you're using a tool like this. And the other trade-off, which is for me personally impactful, is the fact that you're using SQL, right? Because I'm used to using Python to do almost anything today. So for somebody like me, there is a learning curve. You have to get back into SQL, and there's no GUI that you can use instead. But for your business or for your project, there are some benefits that come from that, right? And first of all, for somebody that is non-technical, SQL is way more approachable than Python. And that's the thing. In my experience, non-technical people find programming languages like Python intimidating, and SQL less so. And that means that you're able to collaborate easier between team members. You're just less prone to siloing, and they can go in and actually change the transformations themselves. And the other thing is that one of the benefits that SQL has, if you compare it against, you know, the combination of multiple libraries and frameworks and languages, is that SQL is very stable. So first of all, it's unlikely to be obsolete, but more importantly, you're not likely to run into issues that have to do with like versioning, drift, and things like that. Since you're critical, you know, you're using a stable proven technology for what is likely to be a critical technical piece. Yeah, but those trade-offs, I mean, that does have an impact, right? So I'm kind of curious to hear how people think this would affect, you know, their work in their organization.
Actually, for me, I think the first thing that comes to mind is the selection process, whereby an organization decides, you know, we have like analytics needs. We're going to go around and get some tools to help us with that. I think it'll be interesting to see, you know, in your experience, what has been what that process has been in terms of determining the tooling and implementing it.
Oh, in terms of determining the tooling.
Because when you think of trade-offs, you know, there's every tool has a trade-off. Like we just talked about DBT and what it does well in that regard. But in the past, like what was the experience like to try and go and determining a tool for your organization? What was the selection process like? And ultimately, you know, when you compare, you know, apples to apples, so to speak, across different tools, what were some of the trade-offs that your org was willing to do in adopting particular technology?
I mean, in my experience, and I'd be very happy to hear other people's opinion on this, but in my experience, you know, end users, if you're looking at people that are using, for example, reporting tools, find it fairly easy to jump into DBT because it, you know, again, it is using SQL. And once you see the folder structure, it is relatively self-evident, right? So it's not as intimidating as other tools. If you're using other tools, somebody's gonna have to come to you and ask you to find free time to enable them, basically. So it's definitely more approachable. That's what I've seen.
I think in my own experience, it was like two extremes. On one end, it was the tools that the developers felt more comfortable with. So if you had like, you know, you like Python, you gravitate towards like Python tools and suffer the consequences of that choice. And I just pick Python as an example, but you know, there were a variety of tools. And the other extreme was basically, you know, ease of use. So it's like, let's get something that everybody understands and that everybody can use, even if it means that it comes with a baggage of other tools that you have to kind of put into the mix to make that low entry point. So those are, you know, the two patterns that are observed for the most part.
Yeah, and I've seen that as well. And I think whenever you're dealing with tool selection, you have to pick your emphasis, right? And when you're emphasizing for a simpler tool for this, it gives you the bandwidth to focus, to use your Pythonic skills to do, for example, you know, data analytics or machine learning or something where it's really going to provide value proposition. For me personally, like building these kinds of pipelines with Python, it's really satisfying. Like it's like doing the ultimate Sudoku, you know. But the end result is that it is a lot to manage, and there's a huge learning curve, and it takes a long time to bring other people into the fold.
Yeah, that's actually the first thing that came to mind. You know, thinking on this, like the immediate. I wouldn't call that a trade-off necessarily. Well, I mean, kind of. SQL has the advantage of being the lingua franca of most specialists, either on the data or the programming side, right? Like everybody that knows how to code an app likely knows SQL, and then on the other side, well, everybody that knows how to do data knows SQL, right? Like they have to. So in a world where we're trying to break down data silos and we're trying to integrate data across entire organizations and try to not limit it to departments, to me, making a move in that direction, like where SQL becomes kind of the foundational language with which you interact with data at every step, right? Like not only querying but transforming as well. That's a great way to harmonize your team and get everybody to work together, right? That's kind of what you were saying earlier, but you made a lot of references to less technical people, when at the end of the day, I think it's really just a matter of being like less, I guess, app dev centric people.
Well, even for a very technical person, you're always trying to minimize switching costs, right? And when you're able to specify multiple things with one language as a SQL, inevitably you have less switching cost.
Yeah, that's a good point. That's a good point.
How about you, Milan, Jean-François? What's your impression of this?
Yeah, trade-offs. Yeah, we have like a group, different peoples with different skills. Like you have data engineers mostly working on pipelines, data warehouses. We have BI developers mostly working with tools like Looker, and we have the data analysts, which mostly do SQL. So it's a bit hard to put everybody together and try to find workflows. How are we going to work with these tools? And follow best practices and have like code reviews, code versioning, and CI/CD deployment and stuff like that. Because at our place we have tools that are not always friendly for a developer workflow. Like for example, trying to implement a ZEPL to provide like notebooks to our data analysts so they can write Python without having to know all the basic stuff of Python, how to build a virtual environment, just providing stuff ready to use for them, so they just concentrate on what they know, like data analysis, and just writing the minimum amount of code that they need to. But there are trade-offs in those tools and how we work with them. So we're trying right now to define like good practice workflows around the tools that we have in the organizations. So me, I'm a developer, so I want to have all the best practices with code versioning, etc., and reviews. But on the other side, not all people knows about these developments workflows. So this is kind of trade-offs that we have when choosing tools and trying to develop stuff.
I guess same thing here. If you have different, if you have tools that don't work well with CI/CD pipelines, or are not easy to use under version control like SSIS, it's just a nightmare. It's very difficult to work on anything larger scale. So going towards something that enables CI/CD or DevOps or Dataops, that it's called these days, it's actually not a bad thing. And the other thing is, I guess what Jean-François was saying is that you have different teams. So like what the current data landscape, the way it looks like, you have different teams. You have your data lake team, you have your extraction pipeline team, you have your traditional data warehouse people that live in star schemas and whatnot, and you have your BI people, and everybody is speaking completely different language. It's very, very difficult to put it all together to make a cohesive team that can deliver that can deliver basically functionality all the way from extraction to BI. You would need currently you would need a cloud engineer that can stand up something for the extractors and then actually build them. You need a data lake people that can load the data using Databricks or something like that. Then you have the modeling people, and then the data warehouse people, and then the BI people. So you need maybe 4 or 5 different skill sets to get the stuff done. Going towards something that just requires SQL, that seems to be very good trade-off to make. Yeah.
Anyone else? So yeah, I mean, honestly, for myself, again, I'm also a, I like to do everything myself. If I could reinvent the wheel, I would, to be perfectly honest. But there's definitely like from my point of view, there's definitely like it's a tactical choice to have all this done in SQL, and kind of have that benefit your organization throughout, right? And having less to manage, like in my view, it just improves your bandwidth, which is very limited today as the complexity of everything is growing, right? And what we call best practices is inflating. So this is a constant concern for me. I've left some resources. It's very easy to find DBT's documentation. But if anybody's interested in learning it, I highly recommend just running through the introduction. It's very quick and it's pretty thorough. And if anybody wants more serious security around securing workspaces to secure their development environment, I also have a link which I will share in the chat.
Will those slides be made available to everybody?
I believe so.
Okay.
No, I mean, how would you recommend we distribute the slides?
Well, typically you can either share them as a what's the name? Either a slide share or a PDF that we can post on the page,
Okay.
on the meetup page.
We're getting to the end. I just wanted to remind that we also have the Slack channel going on. I'm going to post the link after, where we're trying to get people to have these conversations online as well.
Yep, very good point. So yeah, we're actually hosting this Dataops meetup across Canada right now. So we have one in Montreal, one in Toronto, one in Vancouver. We're trying to build a Canada-wide Dataops community. So you guys are very welcome to join us over there. I would also like to ask you all to volunteer yourselves if you want to present something, if you think you have something interesting you could bring up or contribute to the group, would be very appreciated. This is a community event, of course, so we really want to make the emphasis, to put the emphasis on the community. Today we had Nasko and Neji both from Infostructs, this meetup sponsor at the moment. But we would like to not always keep it in the family for the next few ones. So definitely, please do reach out. Excellent. Well, if we're reaching the end, I would really like to thank both Nasko and Neji. This was a great presentation. So maybe give like an awkward Zoom hand. Okay, I'm the only one. All right, thank you. If there's anything else, please feel free to stay on and have a quick chat. We'll keep the Zoom open for a few more minutes. And apart from that, I thank you for your attendance, and I look forward to seeing you again at the next event.